All right, let's dive into the invisible world that powers pretty much everything you do online. We're going to decode the alphabet soup of APIs, the secret messengers that make your social media feed, your banking app, and your video calls just work. I mean, really think about it. How do all these different apps, built by totally different companies, on totally different systems, all manage to talk to each other? Well, the answer is this fascinating family of technologies, and each one has its own unique personality. So how do they pull it off? So at their heart, that's what APIs are. They're the digital messengers. They're the rules of the road that let different pieces of software communicate, ask for information, and get things done. Let's kick things off with the one you've probably heard the most about. And honestly, this is the best analogy out there. It just clicks. You, sitting at the table, are the client. That's your app. The waiter is the API. You give your order to the waiter, who then takes that request to the kitchen, the server. The kitchen prepares your food, gives it back to the waiter, who brings it right back to your table. Simple, right? It's an effective and universally understood system. And that's pretty much exactly what our REST API does. It uses a super clear, simple set of commands, like get to ask for data, post to send new data, or delete to get rid of something. But the real magic word here is stateless. All that means is that every single request is a brand new conversation. The server has no memory of your last request, which sounds bad, but it's actually what makes REST so incredibly flexible and easy to scale up for millions of users. Now, that casual waiter approach is awesome for most things on the web, but it's not right for everything. I mean, when the stakes are really high, like, say, you're transferring money, you definitely need a different kind of messenger. You need something way more buttoned up. And boom, this analogy just nails the difference. If REST is a casual chat with a waiter, SOAP is a notarized legal document written in triplicate. Every single message has to follow incredibly strict rules. It's all wrapped up in a specific format with an envelope, a header, and a body. There is absolutely zero room for misinterpretation. So here's the key thing to understand. SOAP isn't dead or obsolete. Not at all. It's just highly specialized. It's the standard in these high-stakes fields because it has security and reliability baked right into its DNA. When a message absolutely, positively has to get there correctly and securely, SOAP is still the king. So while REST and SOAP really set the stage, the next wave of APIs was born out of two new and massive challenges: the need for just raw, blistering speed and extreme efficiency with data. And I'm not just talking about your website loading a little bit faster. I'm talking about the kind of speed you need when you're coordinating thousands of tiny little services inside a giant company like Google or Netflix. For that kind of work, you need a totally different kind of engine. This is the perfect way to put it. gRPC was built by Google for one thing and one thing only: performance. It completely throws out the human-readable text that REST uses and instead uses something called protocol buffers. This basically squishes the data down into a super compact binary format that computers can process insanely fast. And the results are just staggering. We're talking 7 to 10 times faster than a standard REST API in a lot of cases. That's why it's the secret weapon for all those massive internal systems. Look, you wouldn't take an F1 car to the grocery store, but when speed is the only thing that matters, gRPC is in a league of its own. Okay, so that was the speed problem. Now for the efficiency problem. With REST, you often get stuck in one of two annoying situations. On one side, you have overfetching. You ask for just a person's name, but the API sends you their name, address, friends list, and their entire life story. It just wastes data. On the other side is underfetching, where you have to make 3 or 4 separate trips to the server just to get all the data to build one screen on your app. It's just slow and clunky. And this is where GraphQL, which was created by Facebook, comes in and totally changes the game. See, instead of the server deciding what data you get, you decide. You send a single, very precise query that says, I want the user's name, their profile picture, and the titles of their last 3 posts. And that is exactly what you get back. Nothing more, nothing less. One trip, perfect data. It's brilliant. Okay, so everything we've talked about so far follows that same basic model, right? Your app has to ask for data. But what about when you need to know about something the instant it happens? What about when you can't afford to wait and ask? Well, this requires a complete shift in how we think about communication. This analogy just perfectly explains that shift. Using a traditional API is like walking out to your mailbox every 5 minutes to see if the mail has come yet. It's super inefficient. Real-time APIs are like the delivery driver ringing your doorbell the second a package arrives. The data comes directly to you. And in this real-time world, there are three main players. You've got webhooks, which are the simplest. Think of it like a doorbell. The server can ring your bell, but you can't ring back. Then you have WebSockets, which is like an open phone line. You and the server can talk back and forth constantly. And finally, WebRTC. That's like a direct video call with no operator in the middle. So how exactly do you get that open phone line going with WebSockets? It all starts with a special move called a handshake. Your browser sends a normal request but asks for an upgrade. If the server agrees, they shake hands, and bam! That connection is now a persistent two-way tunnel. It's perfect for things like live chat apps or real-time stock tickers, where data is flying back and forth. But even with that open phone line, you've still got the server in the middle of the conversation. And for some things like video and audio, that middleman just adds a tiny bit of delay. So WebRTC asks a really powerful question. What if we could just cut the middleman out completely? And I guarantee you've used this. The last time you were on a Google Meet or a Zoom call, that was very likely WebRTC. Your audio and video weren't being routed through some central server. They were being sent directly from your computer to everyone else's on the call. This peer-to-peer connection means way less lag, which means fewer awkward pauses. It's the magic that makes modern video conferencing feel so instant. So after exploring this entire zoo of technologies, from formal contracts and waiters to F1 race cars and direct phone calls, what's the big takeaway? Well, it's actually pretty simple. There is no single best API. It is always about choosing the right tool for the job at hand. And this slide right here is your ultimate cheat sheet. It brings everything together. REST is your all-purpose waiter. SOAP is your ironclad contract for when security is everything. gRPC is your race car when you need pure speed. GraphQL gives you that surgical precision. And the real-time trio, webhooks, WebSockets, and WebRTC, give you the doorbell, the open phone line, and the direct call. Each one is a specialized tool for a specialized problem. You know, when you look at this list, you're not just looking at technology. You're looking at different philosophies, different ideas about how our digital world should connect. And as our demand for faster, more seamless, and more direct communication just continues to explode, the real question isn't just which tool is right for today, but which of these powerful ideas will end up building the internet of tomorrow.